So now, rather than going forward in more technical direction, I'm going to pivot to a research direction. I have noticed that this issue has been coming up again and again. So, can you guys guess what it is? Yeah, so I'm talking about occlusion. I think I noticed that I have spoken about this again and again. And so, occlusion is basically when something important is hidden behind a vehicle's view, like a pedestrian hidden behind a vehicle. So, for example, imagine a truck blocking a pedestrian at an intersection. So, one vehicle may not see the pedestrian, but another vehicle approaching from a different direction, it might. So, my next research question becomes that can a vehicle use information from other vehicles, right? From other vehicles to better understand or to understand what it cannot see itself, what it cannot see itself. Like it will be in its vicinity, but it will not be able to see it just because it is hidden behind some or the other obstacle. So, and this simple question, it connects everything we have discussed so far. Autonomous vehicles, now we know that it has sensors, but the sensors they have limitations. So, to solve that, V2X allows vehicles to share information, and together they can potentially create a much better understanding of the whole environment that it is present. Now at this point I don't want to just just keep learning concepts. So I want to move into the research side of this topic, that I started with V2X CAV technology. So what I'm going to do is I'm going to directly go deep into reading research papers and see what has been done, and then I'm hoping to find an interesting research direction. So I'll start with a simple Google Scholar search and search for papers with keywords like, so let me just write it down. Keywords right now, what I know is what V2X, I know, and then I'm further moving towards occlusion. And right now, it's a long process, so I want to do a quick survey. So I want to see what papers have already been done. So our survey paper, it actually covers all those things. So it will be a long process, in how I'll handle these research papers. As so, just a brief, diversion from this current topic. I just wanted to discuss that. There will be where I'll be, handling a lot of research papers right now. So as there will be a lot of information that I'll be going through. So first, I'll start with the paper rather than showing my whole process. That will be more fun, I think. So a quick note on all the applications that I'll be using to store and compile all such information. So I'll keep it simple and just use Excel sheet for a master research database, and then simple Microsoft Word for a like a one-page summary for each paper that I read. So applications that I'll be using right now when I'll be dealing with so many research papers will be Excel sheet and Microsoft Word. So you guys don't have to follow the same pattern. You can use your own comfortable application that you would like to follow. And so let's go to the Google Scholar now and start with the keyword V2S occlusion survey. And I aim to study the latest papers first and then move to the older one, because but only target like last 5 years papers. So I've already opened the Google Scholar and I've typed V2X occlusion survey. So over here, so these are some of the papers that I found over online, and I think the paper with most citations was this one. So this paper now, and you can just directly view PDF, and it'll show you the whole paper. So this paper, this is which I've already found actually. So this will be great for a beginner level understanding of the topics like V2X and occlusion and various work done in this field. So I selected this because it has a good amount of citations. I think I've already said that. So but don't get overwhelmed with all the information on this paper. It's like a 34-page paper, and paper is like vehicle to everything cooperative perception, CP, for autonomous driving. So let me show you what I'll start with, and I will create a folder with this project and create one folder that will contain all the papers that I'll read, and as I keep going on learning. So I created this folder and V2S occlusion aware VRU, and just create a folder with papers. This is where the paper is right now, and then so let me just find it somewhere. And then the other thing is I have created one literature notes file and one V2X CV literature file. This is the Excel file and this is the doc file, Google Doc file. Simpler, a simple Microsoft Word file. So I think I have covered. So there will be a Word file for now, and that will contain the key information about this paper. So I have a template already written. So let me just come over here. So I already have a template that or I have already written, like what all information I have to concentrate on while when reading a survey paper, and when reading a or when and when reading a research article. So let's get into the paper first. This so over here. So this is the paper title, and these are the authors. So this is for properly crediting these authors. So after going through this abstract, I have already read this paper a bit, so I'll just talk about it in a quick way. So after reading this, so you guys can you can read it at your own pace and see if your points align with my points on the abstract at least, or you guys can follow me along and directly see what I've learned from the abstract. So after reading that this abstract, I understand that this paper is a survey that explains how autonomous vehicles can work together to see better than any single vehicle can on its own. And I think that was the overall goal, to pivot towards occlusion after seeing the same problem being discussed repeatedly. So as I said that the paper, so I'm just writing it down so that I know where my how my this is just a good way to handle my notes. So let me just write what I'll learn from this paper, everything. So after reading the abstract, this is what um, I learned. Like, this is the problem that it is trying to solve. Like a single autonomous vehicle can't always see everything, right? This is what the main problem we are trying to solve. Like a single vehicle So these are my own notes, and these are basically, I'm not going to cover the whole paper over here like piece by piece. I'm just trying to see what is important. I'll show you what was my template that I'm going to cover in my for my literature survey, and there will be a separate over here in whiteboard. I'm going to just cover a brief tutorial what I'm learning through it. So obviously, I'm not going to stop doing that. That is obviously, this is actually a key part in this journey, so that afterwards I can come back and see what I've learned and I was doing at that time. So can't always um, see everything. And occlusions, like blocked views, like what occlusions, and then limited sensor range. When we discuss about different sensor like lidar, camera, radar, so I think I also discussed about the ranges, and in different environments. And then what complex environments, so that was another challenging scenario. So basically, what we are trying to say is autonomous vehicles field of view is limited, and it cannot see around corners, through trucks, or behind buildings. So the solution is what V2X cooperative perception. So that was the problem that I saw, and then after reading through this paper a bit, the solution that I saw, that is present, is V2X cooperative perception. So I'll discuss more about this in some time. So let me just write these down for my own note sake. CP. And what is cooperative perception? Cooperative perception is nothing but when vehicles share perception data. Okay, that's more like a I'm just talking about. So perception is, it means how it's seeing the world. Perception means how it is uh, getting the data from lidar, getting the data from radar, and what else, camera and GPS, and then trying to see what it's seeing around its own environment. So that is like perception. So vehicles shares perception data with each other. So that is nothing but vehicle to vehicle communication, and with infrastructure. This is V2I. So I understand that. Okay, so my goal over here would be to first of all extend perception range. So these are all that I understood from the abstract. Let me just remind you guys. So that is that the paper or the authors will also cover this. So the goal is to cover these topics, then how extending perception range helps, what other work has been done. So we'll go through that one by one. So but let's have a brief overview from the abstract itself. So perception range. Then another thing that I saw was increase detection accuracy, like sensor detection accuracy. Another was to support better decision making. I know some of you might be looking for something interesting. There's a lot of writing over here, I know, but that's how the research is usually. You have to write a lot, you have to understand a lot. But yeah, for those who like a bit of a drawing, so let's see over here. So this will basically enhance situational awareness. So instead of fixing every sensor, let vehicles share what they know. So what I have learned till now, if I want to wrap around a brief diagram around it. So suppose this is the road, right? This is the lane distributing line, and then there is this car A. Okay, I'm bad at drawing a car, so obviously, please, yeah, let's see. So this there is this car A. Let me put some and more look like a, okay, yeah. How does that look? Okay, so this car, suppose it's going this way, right? And I think I need some more space, so let me just bring it down. Let me increase my road length. And then what happens is, if the car is going over here, it is in moving state. And what if there is a truck that is parked on this side? So there's a large truck that is parked on this side. And so what will happen is, this car is moving and it cannot see people around, if the people are like over here, right? And they're moving, they're trying to cross the road, something like this, like if it's a so if they're crossing. So how will this car know, okay, there are people that are going to cross the road? And if it's speeding at 45 miles per hour, obviously it will take some time to stop by the time it sees these pedestrians. But then what V2X says is that this car K can interact with car B. It can take its help. So yeah, so it can take this car B help, which is going in this direction. Yeah. So obviously we can see that this car can see these pedestrians, and after seeing these pedestrians, this car can communicate with these people, or like share information. And this is nothing but cooperative perception. So this thing, what it sees, it shares that information with car, and okay, now car knows that, okay, there is a pedestrian that is coming right now, and which is hidden behind the truck. So this is a okay, this is, I like this diagram. It kind of creates a whole overview of what we are trying to solve, what are the challenges. So this is a real challenge that with where we can save a lot of lives over here, guys. So for me, it's a good motivation. So the cooperative perception, the CP, it helps in three major ways, as this paper indicates. This is again from the abstract itself. So let me just write it down for my own sake. So CP benefits, I can later come back and see what I've written. So CP benefits, what first one was extending perception range. Another is increasing detection accuracy. Then third one is better decision making. So a vehicle normally sees what its sensors cover, right? But with cooperative perception, it can see around corners, behind trucks, as I think as that figure explained, and outside its own sensor range too. And then in some cases, a vehicle camera it detects a cyclist, so and its lidar detects an object. So this is a simple case where a vehicle camera detects a cyclist, and but its lidar it detects an object. So it is difficult to make a decision in such cases. But with V2X, another vehicle can share what it also sees, what it sees from its own perspective. So that confidence level increases and detection becomes more reliable. So the paper will also discuss some key techniques for enabling reliable perception sharing, better handle such kind of data. First one is agent selection, that is which decides like which vehicle or infrastructure to cooperate with. So let me just write it down a bit more. So like decides which vehicle to cooperate with, because in a dense environment there will be so many vehicles that will be seeing, so there will be perceiving their own environment. So there has to be a agent selection, like from which vehicle do we need to cooperate with in such kind of overcrowded traffic. Then second is data alignment. So data alignment it covers like synchronized data from different sources, data from different sources. And third one is feature fusion. Feature fusion like combining those perception features from multiple vehicles into a single data, or like understandable data. So combines perception features from multiple agents into a unified understanding. So like if 50 vehicles are nearby, what do you think? Should everyone transmit? Probably not, because which vehicle should share information. This is more like an agent selection. And then different vehicles have different GPS locations, or different clocks, different viewpoints. Then how do we assign all these observations? And lastly, it's future feature fusion. So from the abstract, the paper will also discuss more major challenges and future direction, and that's exactly what I'm actually interested in. And that's my gold mine for this domain, and I think for anyone who will be following my channel, following these videos, and then going to read that paper. So that would be your gold mine too. So the introduction section covers that this paper is about V2X. Again, so after abstract, I went to introduction, and so just a brief overview that that introduction it basically covers that this paper is about V2X cooperative perception. So basically, it sets up the problem, that is occlusion and limited range, which we have already discussed multiple times. So I will not spend much time on this, and I'll move forward with other parts of this paper.